All right, guys, we're back. So, all right. So, any ideas? What's the error here? Is
William,
there an error?
is it because we don't have the super keyword?
Well, I mean, it gets put in there automatically, doesn't it? We showed that. Let's see. Let me go back a few slides. Here. Remember, it got called automatically. Like, see, the super keyword wasn't used anywhere in any of these. Remember, you're on the right track in terms of the super. What's going on with super? But here the compiler automatically puts it in there for us if we don't have it. You're on the right track. Let's see. Yeah, so Conberg. Okay, so right. So let me kind of show you. So I pulled it up over here. So here I saved it. All right, and if I try to compile it, I get this ugly compiler error. Oh, actually, hold on. You'll start a character stuff. That's right. Get a couple of, should get like 2 compiler errors, I think. Yep. Constructor fruit in class fruit cannot be applied to given types. What? But I don't even see a constructor in the fruit class. Okay. Remember, this is what is automatic. Okay, what is automatic, right? Is if our class has a parent. So we use the extends keyword to say this is the child, this is the parent. Apple is a type of fruit. Okay, so now we didn't explicitly create a constructor, but because all objects need a constructor, Java automatically did this. Created a constructor with no arguments and no code. That's it, right? Well, not exactly no code, all right? Because what did we see on that slide before here? We saw this, right? So what really happened is there was a super keyword applied there, right? Okay. So what we typed was this. What we typed was this. What the compiler automatically did for us was this. Okay. No major problems yet. Well, until we get there, right? But we needed to call a constructor for its parent class, fruit, with no arguments. But here's where the problem is. We created a constructor for the fruit class, which means what the compiler did was before we had created this, okay, so if we didn't have that, our compiler had created this for us, right? But when we went and did this, when we added a constructor ourselves, when we explicitly created a constructor ourselves, the compiler said, oh, you made a constructor? You don't need this anymore. Okay. So because we created our own constructor for fruit, the compiler got rid of the automatic constructor, the no argument constructor it had created. All right. And so when Apple tries to call a no argument constructor, then here we go. There's a problem. All right. So how do we fix this problem? Well, there's a couple of possibilities. All right. At least 2 I can think of. All right. One is that in order to make sure that Apple, when it calls the no argument constructor, it finds a no argument constructor, is we add a no argument constructor. That does nothing. Okay. So now we added this. When we go to compile it, we should get no problems. Done. Compiled, no problems. Okay. Another possibility for how to fix this, how to get rid of at least the compiler error, is we could add a constructor ourselves that calls the constructor of the parent class that does exist. This should also get rid of our compiler error. Okay. So if we don't call a constructor ourselves, if we don't explicitly call a constructor, the compiler tries to automatically call the no argument constructor. All right. If we tell it to call a specific constructor, it does not try to call the no argument constructor of the parent. Okay. This can be kind of confusing, so you make sure that like you kind of look into this better. If you aren't understanding, if you're not following what's going on here, make sure you look into it better, because this is one of those things that it's hard enough to explain in person. It's very difficult to explain online like this. So I encourage you to look into it, play around with it. What happens when you take this out? What happens when you take this out? Why does this give me a compiler error? Right? Okay. But it is very important to understand. And I went back and looked at it during the break. This was the issue where I did the reclam with it, where what happened was, forgot to open up the other one. Test anyways, right? So I had this where I called a no argument constructor, but I said in the video, I was like, I'm just going to delete this because look, it doesn't do anything. There's no code there. It's like there's no point to have this. Why do we have this? Right? I compiled it and my Java class, it's fine. Everything's great. I send this off to my Hoja, to Berk, so he can grade it. And when he goes to compile it, he gets a compiler error. What? Right? Why? Because it's trying to call the no argument constructor, but there is no argument constructor, right? So we have to put explicit no argument constructor in here that we compile, and then this will compile and run. All right. So it may look like it's not doing anything, but it actually is doing some things. Okay, so make sure you understand the why this resulted in a compiler error and why the two solutions I proposed as possible solutions. Add a no-ar constructor to fruit. Add a constructor that calls the 1R constructor, 1R that calls so either add a constructor here in fruit that's no arguments, or add a constructor in here to Apple that calls the super with a string. Okay, those are by no means the only solutions, right? But they are two possible ones that will get you, that will at least get rid of the compiler error.
Hoja?
Question?
None of these two existing causes error, right?
Right
Compiler
now,
error.
way it is right now would cause a compiler error.
If we add both of them, does it still add a compiler error? I missed that.
Like if you did both of these?
Yeah, at the same time.
Oh, let's find out. Let's see. So we run and we do this. All right, no compiler error, right? And it makes sense, right? Because now we have a constructor, and the constructor they're calling is this one here. All right, so this becomes just extra in this case. Okay. So yeah, you could do one or two or do both of them together. All of those will get rid of a compiler error. But let me caution you again. I think I may have said this to you before in years past. Be careful that assuming that no compiler errors means that your code is correct, right? Because which one of these is the correct solution to our problem that we encountered? Adding a no R constructor to fruit or adding a constructor that calls super to apple? Which one of these is the correct solution? One or two? Was that?
Both of them are correct.
Well, I wouldn't say both of them are correct. I'd say in this case, I was trying to see who would say it depends, right? But in this particular situation, both of those function slightly differently, and it's really a matter of what the customer wants in that situation. So you'll probably need to go back to your customer to figure out what is it that they're really trying to do with their whole apple and fruit classes.
But is there any difference though?
There is a difference in how it functions. So for example, if we were to say, oh, well, let's just add a constructor that calls superstring to apple. So let's just do that. Okay. So this gets rid of my compiler error, right? But what happens if now we add this? Now we're going to have the same problem that we had before, right?
Yeah, because it will count
Right.
apple.
But if we had solved the problem doing this, let's see if we solved the problem doing. There's nothing, and compile it. Right, we get no errors. We can add as many different fruit types as we want like this and get no errors. All right. So it's a question we have to figure out, right? And again, it's all about how the functionality is supposed to work. Because do we want to force all of our children to have to call this? Maybe we want that to be something that's forced. Sometimes putting things in that will cause compiler errors for future code is a way to force them to be written a certain way. Okay, so it can be useful that way. All right, so back to our slides. All right. Okay, now we have this whole subclass, superclass, subclass thing we were talking about, right? So a subclass inherits from a superclass, right? We can also, so it gets properties, attributes from the parent, it gets methods, right? We can also add new attributes, add new methods, and we can override the methods of the superclass. So this is different from overloading, okay? Overloading is writing a method with the same name, but it has different parameters. There's a different signature. Overriding is saying there's a method that exists in a parent class above me. I'm going to override that and make it a new definition. Okay, so you can call superclass methods using the super keyword. Now, in this case, super does not refer to the constructor. It is the class above. It is the parent class. It's saying I want to use the get date created of the method, the super method of the class above me. So, all right, so we can write it such like this so that it uses the date created of the parent class. But some methods we might want to override. We might want to say, I don't want to use the parent method. I want to use my own, right? And so what we can do is we can override the toString method by saying, let me define it the same way. It needs to have the same return type, and it needs to have the same name, and it needs to have the same parameter list. Okay. And now notice that I'm using the parent method, the toString method, right? I'm using it as part of my toString method, but I'm adding to it. Okay. So I'm saying I want this to use the parent method as it exists, but then I also want to do some other stuff, and I want this to be the toString method for circle. So what's going to happen when this executes? It will get the value for the toString method from geometric object. It will then concatenate the radius is radius to that, and then it will return that new value. Okay. Now, a method can only be overridden if it's accessible. So a private method cannot be overridden because the child class can't see it. Okay. A private method, remember, a private method or a private attribute can only be seen by the class that it's in, which means even children cannot see the method or attribute of a parent class if it's private. Okay. Some things parents need to keep hidden from their children. Right? Okay, so if a method is defined in a subclass, is private and in superclass, the two methods are just completely unrelated. They are not the same method at all. Okay. All right. Let's see. An instance method, a static method can be inherited. A static method cannot be overridden. Static means stable, it cannot be changed, right? Right. If a static method is defined in the superclass, redefined in the subclass, then the the method is hidden, so it's no longer seen anymore. Let's see. All right. So overriding versus overloading. Again, one of the things I said was that these are not the same thing. Remember, overloading is same name but different signature, different parameter types. Overriding is the same name and the same parameter type. It exists in the parent and the child. Okay, so here are two examples. This first one overrides, the second one overloads. Okay, so let's take a look at what happens with these two. Okay. Or I can copy the text. might not like me. There might be a hidden character or something in here. Let me see. Okay, good. All right. So class A extends B. Okay, remember what that means is that B is the parent, A is the child. So A gets everything from B. Okay. Now, I'm going to create a new object of type A. Okay. Now, when it goes to call this, okay, yeah. Okay. When it goes to call this method, it's going to look for a method called P. It's first going to look for a method called P that has an integer type, right? Wait, I went to the wrong screen. There. It's first going to go and look for an integer type, but in A, there is no P with an integer type, is there? Okay, so then it's going to look for something that's close enough, right? That's close enough, so double, right? So it's going to print 10, right? So it's going to jump into this method here, right? And print 10.0 because it's a double that was passed. It took the value I and put it into this double variable I, right? Sorry, value of 10 and put it into this double variable I. Here it's going to do it the same thing again. Okay, but our other example, when they showed it to us, a different thing was they changed this where A extends, A's method is an integer type. Okay. So now, when I go to run this, all right, first thing it's going to do is going to look for an integer type, right? And it's going to find it, and it's going to print my value, 10. Okay, now this is where it gets interesting, right? Because it's going to look for a double type, a P method that's a double type in A, right? In the A class. Okay. Is this a P method that takes a double parameter? Does this match?
No,
No,
it's
this doesn't
integer.
match, does it? So runtime error? Because it doesn't have a method that matches this, but this, if this didn't have a method that matched this type, that should have been a compiler error, not a runtime error. So it must go somewhere. And we'll see it goes here. Okay. And the reason is because A inherited this method from class B. We didn't change this method to become this method now. These are two separate methods in class A. Okay. These are two separate methods. A has access to this method because it extends from class B. A also has access to this method because it was created in the class A. So we print out 20 instead. Okay. So let's go back to the way it was before and show that one again. Why? You mean like when we do that? So this is what we had before. Okay. We simply changed the data type from double to int, or int to double here. Okay. So now this overrides the method above, which means now A, our class A, does not have access to this method anymore. As far as A is concerned, this method doesn't exist. The only method that exists that's called P is this method here now for A. Okay. All right. So question now, ready? Which is going to take priority? Okay. So now I have an int method in class B and a double method in class I, but I'm calling it from A. So is it going to, when it gets this integer here, is it going to say, well, I want to use the A method if I can, which it works, it fits, it's good enough. Or is it going to say, no, I want to use the int method because that's the right fit? Or are you sharing thoughts? Nor, do you have a thought to share?
So I have a question. Like,
Sure.
if we create two constructors, okay, and we initialize it for the same thing, like string A or string A. The first one we print 1, and the second one we print 2. And if we run, which one is going to appear first?
Like, you may need to type that up to show me what you're saying, because I'm two constructors,
okay.
a parent and a child. Yeah, it has to do with inheritance. Yeah, no, the question we're asking here is it going to try to use the A method only, or is it going to try to go up here and use the int method because it's the better fit of the parameter? I'll let you guys. Okay, so Batuan says to use double. 2 people have agreed with him. Anyone? Anyone? Let's see. It went for the integer. It went for the integer. Okay. Let me show you. Let me show you the why. Okay. So when class A extends B, the first thing that happens is all things that exist in class A, methods, public methods, public attributes, all get copied into class A. Okay, that's what the compiler does. It doesn't, you don't do that, the compiler does this. Okay, then anything else that we explicitly type for class A is also seen. So now remember, this becomes like what? It's an overloaded method, right? So just like we showed last semester, if when he goes to try to find the P method, it says, let me find the best fit. It's that one. So it uses this one. Okay. Now, let's talk about overriding. First thing it does is it says, okay, I'm going to copy all methods and all public methods and attributes from the parent class and put them in the child. Now, I've redefined this though. So what this does is it says, okay, the programmer is wanting to change what this is defined as, so I'm now going to remove this. Okay, so if it is overriding, it replaces the existing method, and that method is no longer used. If it's overloading, both exist in the child class. Okay. Another one of those things that you really need to make sure you understand so that we can, so that you really understand so that you can do well in the assignments and stuff like that, because it can get a little bit confusing. Like, for example, this. So now I'm going to create two B's. Okay. Compiles. Yes. Let's walk through it. So I created my B. Now, which one gets created? Which one does it use?
Double.
Yeah, it has to use the double here because B doesn't know anything about A. Okay.
Yeah.
B is the parent. B doesn't extend from A. B doesn't get anything from A. Just like me, I don't get anything from my children, right? My children get everything from me. I get nothing from my children. I know that's a lie. That's a lie. I get lots of things from my children. All right. Okay. But and my son's on the call, by the way. But in this situation, parents don't receive anything from the children in Java. The children get everything from the parents in Java. Okay? So what that means is B doesn't have an integer P method. It didn't get that from A. It's like, for as far as B is concerned, A doesn't even exist. Okay? So then when it goes to run this, it will run that as well. Okay. All right, so I gave you guys a lot of news, but I do want to, I want to try to do this as much as possible. I want to try to end on a reklam, on a cliffhanger. Do they have a word for cliffhanger in Turkish? I don't know. Okay. Let's talk about this thing here that we've talked about before. All right. So A equals what we started with. Okay. And I said, you guys are going to ask me, why do I have to type A variable name equals new A? Like why can't it just know it's an A over here? It's an A over here. Like, or like earlier you wrote B equals new B. Because these two don't have to match. Okay. And say that we can say B is a new A. Okay. So where we create an object of type A, we create a variable of type B, and we point it to that object of type A. Okay. But this will give us a compiler error. So we can create a B variable and point it to an A object, but we cannot create an A variable and point it to a B object. We can create an A and point it to an A. We can create a B and point it to a B. But we cannot create an A and point it to a B even though we can create a B and point it to an A. And there is a very good reason for why this is, and it has to do with this word right here, and it has to do with the order of how these things go. And we will talk about that in a future lesson. I think it may come up in the lesson tomorrow, but I want to put that out there as a reclam for you to say, wait a second. How can I create a B that points to an A, but I can't create an A that points to a B? All right, so think about that. Maybe if you look into it, try to figure it out on your own. All right, we will definitely talk about it, and I will give you the kind of the understanding of why that works the way it is in the future. All right, are there any questions? Any questions or comments? All right, we will end there for today. Like I said, I gave you guys a lot of new stuff today. So soak it in, make sure you understand it. I'll see you guys tomorrow afternoon. All right, have a good evening.